Welcome back to you all. In the previous lectures, we have seen asynchronous counter, designing of asynchronous counter. We have seen that was having a problem. That is why we have briefly discussed about synchronous counter. Okay, so in that series, we are going to talk about first synchronous counter, that is your ring counter. Okay, in this lecture, we'll see the designing of ring counter, working of ring counter, and why it is known as ring counter. Okay, so for understanding this you need to have a basic of flip-flops, and if you have understood or learned shift register also, that will be very helpful. So first let's go through the designing of ring counter. So for the designing of ring counter, let's say you are asked to design 4-bit ring counter. Okay, so the first thing you have to do, you have to take 4 D flip-flop. You can go with the D flip-flop, or you have to follow the procedure of designing of 4-bit shift register. That's all. Okay, first you have to design a 4-bit shift register. So how will you do that? You will take 4 flip-flops, here we goes, and then you will connect each, this is the clock of each flip-flop now. So the clock of each flip-flop will be connected with a common clock. Okay, that is the difference between asynchronous and synchronous counter. In synchronous, each flip-flop will be connected with a common clock. Here we goes, see, here we have connected clock. Now each flip-flop is connected with common clock. Okay, the next step, I have connected, see, the output of this is connected with this, output of this is connected with this, the output of this is connected with this will make a shift register. Furthermore, there is one more addition in the shift register. What is this? This is this connection. Have a look, see here. So mean, if you consider this circuit only, okay, and exclude this connection, what is in between D1 and Q4, just exclude that connection. So this is your 4-bit simple shift register, but just addition of this connection, or this wire you can say, between Q4 and D1 is making it a ring counter. Okay, so if you are asked to design a 8-bit ring counter, you have to take 8 flip-flops and you have to follow the same procedure. That's all. The output of 8th flip-flop will be connected to the input of first flip-flop. That will make a 8-bit ring counter. Okay, now let's quickly go through the working of ring counter. So in the working of ring counter, first we have to make sure that output of first flip-flop is connected or is set to 1, and rest of the flip-flops are connected or reset to 0. How will you ensure that? For ensuring that, you can use preset and control inputs. If you remember, preset and clear inputs. Okay, so let me briefly tell you about preset and clear inputs also. In preset, if preset input of any flip-flop is enabled, then its output will set to 1 irrespective of the values of input. So I have enabled preset input of the first flip-flop, so its output is set to 1. Okay, now what about clear? If clear input of any flip-flop is enabled, so its output will be set to 0 irrespective of the value of inputs. Okay, so here what we have done, I have connected preset, or I have enabled preset of first flip-flop, and I have enabled clear of rest of the flip-flop. So the output of flip-flops is 1 0 0 0. Is that okay? This is the first step. Now in the second step, when you will just give the clock, as you will trigger the clock, then what will happen? This output is connected with the input of second flip-flop, output of second is connected with the input of third flip-flop, and output of third flip-flop is connected with the input of last flip-flop. So what will happen? This data will start moving now. This one will come here. Just let's see with the help of animation. See, this one has shifted to this. Once again, let's have a look on the animation. This one has shifted here, 0 has shifted here, this 0 has shifted here, and this 0 will shift here. Okay, here we go. See, so this has happened at the arrival of first clock pulse. As you will give the second clock, then this 0 will appear here, this 1 will appear here, this 0 will appear here, and this 0 will appear here. Okay, so that's all. Actually, this is the working of ring counter, and that is how your after 4 consecutive clock pulses, this one what we have taken here, this one will again appear here in this flip-flop. Okay, and this process will repeat itself. So here, as you can see, the output of this entire circuit is representing 4 different combinations. Now, the first combination was 1 0 0, the second combination has become 0 1 0 0, the third combination will become 0 0 1 0, and the last will be 0 0 0 1. So we can make use of these combination. If a circuit is giving you various combinations, or that combination is repeating itself, then we can have various use of that. Okay, so let's for better understanding of that, let's have a waveform representation of that ring counter. Okay, so this is the clock which is provided to each flip-flop, and these are the outputs of these outputs. Actually, here I have represented them by Q1, Q2, Q3, Q4. Here it is represented, because of certain reason, it is represented by QA, QB, QC, QD. Don't get confused with that. So this is the first clock. Okay, as this first clock will arrive, your output or first output of first flip-flop was connected, was set to 1, and rest of the output of rest of the flip-flop was set to 0 0 0. This is at the arrival of first clock. Okay, as you will give second clock, what will happen, this 1 will appear here. Okay, and this 0 will here, this 0 will here, and this 0 will appear here. That's what it is shown here. At the arrival of second clock pulse, what will happen, your 1 will appear here, and the rest of the things will repeat itself. Similarly here also, at the arrival of fourth clock pulse, you will be getting 0 0 0 1. At the arrival of fifth clock pulse, what will happen, this process or this 1 which has started from here, that will again appear to this point. Okay, now the pattern, what is the pattern actually? If you look for the pattern, initially the pattern was 1 0 0 0, and then 0 1 0 0, then 0 0 1 0, then it has become 0 0 0 1. Now again it is going to be 1 0 0 0. Okay, so this is how this will repeat itself, and you will be getting various pattern from this circuit just because of these repetition, or it's creating a kind of ring, like from where we have started, we have reached at that point again. That is why it is known as ring counter. It is having various applications, like if you simply connect this ring counter with a series of 4 bulbs. Let's say you have taken 4 bulbs, or 4 different colors, you can choose any of your choice, and the output of these flip-flops QA, QB, QC, QD, okay, are connected with those bulbs. So what will happen, at first your first bulb will glow, and when you will give the second clock pulse, your second bulb will glow, and at the arrival of third clock pulse, your third bulb will glow. At the arrival of fourth clock pulse, fourth bulb will glow. So that is how you can have a pattern. Okay, there are various other applications of this ring counter. Next is your Johnson counter. We'll see that in next lecture. Thank you very much.